welcome back to Lake Math. Today we're going to talk about continuous, discrete, domain, and range. Depends on how your algebra book's set up, but some of them, the one for our school, I'm not going to name any brands or anything because maybe I need ad money from them later on, and my attorneys are not as good as their attorneys, so I'm not going to say anything about that, but a lot of books want to put continuous, discrete, domain, range, and if it's a function, not a function, if it's a line or not a line, all in the same thing. That's just too many concepts in one lesson. So first, we're just going to worry about continuous and discrete. Continuous means everything is connected. So a line would be continuous, a circle would be continuous. Basically, anytime you can have part of something, it's going to be continuous. Discrete means dots, right? So if we're looking at a graph, it's going to be dots. If we're looking at several coordinates, it's discrete. A table is automatically discrete. So examples of continuous would be speed, because you can go 12.23 miles an hour. Weight, you can be 156.5789 pounds. Time, we've got seconds and milliseconds and whatever. So decimals are okay, it means it's continuous. Examples of discrete. People, if we have part of a person, something went wrong. We need an ambulance, we need someone to come in here and clean up this blood. Why do we only have 0.23 of a person in this room? What happened to the rest of them? Not good. Part of a book, it's not as critical, but, you know, books, we should take care of our books. Cars, if you've got 0.6 of a car, not super helpful. So if it's got to be whole numbers, it's discrete. If we can have part of something, decimals, fractions, continuous. Now, domain and range, these tend to be kind of confusing for people. Domain is all the numbers that x can be. So basically, how far left and how far right our graph goes, whatever x can be, that's domain. So if they're asking about domain, your answer better have an x in it, because they're talking about x's. Now range is all the numbers that y can be. So this is how far up and down our graph goes, and if they're asking about range, your answer better have a y in it. If you notice the stickers, I decided instead of endorsing blood pressure medicine, I would let my son decorate. Alright, now the way we do domain and range depends on whether it's continuous or discrete. So first we'll talk about if it's continuous. Continuous domain, we're going to put x right here in the middle, and we're going to put the greater than or equal to's on either side. And now on the left we'll put how far left the graph goes and how far right the graph goes. If the graph goes forever to the left, then this isn't a thing, and we'll just do this part. If the graph goes forever to the right, we'll just do that part. Continuous range. We're going to do the same thing, but we're going to put y in the middle, and then we're going to put how far down the graph goes, so this would be the lowest point, and how far up it goes, this will be the highest point. And again, if it goes all the way down, we'll leave that off. If it goes all the way up, we'll leave that off. Now, if it's discrete, our domain's going to be different. We're just going to list out what the x's are. And for discrete range, we're just going to list out what our y's are. Some examples of this. We've got an equation, y equals 2x plus 3. It's a line, it's going up. Now if you notice, this goes all the way to the left because it's got an arrow on it. It goes all the way to the right because it's got an arrow on it. It goes all the way down because it goes on forever. It goes all the way up. So since it goes all the way left, right, up, and down, our domain's going to be all real numbers, and our range is all real numbers. All real numbers means all numbers, so all of them. Positives, negatives, decimals, fractions, all of them. Now, if I have a table, my domain is just whatever is under the x, and my range is just whatever is under the y. And if you were answering this question, for domain, you would put them listed out. And for range, you would put those listed out. You wouldn't just circle them. Now, if I have coordinates, coordinates are actually the same as a table. I could rewrite these coordinates as a table. First one is 1, 2. Second one is 3, 4. And that one is 5, 6. So your domain would be this. Your range would be that. And remember, with your coordinates, the first one is x, the second one is y. So your domain is this one, and this one. And your range is this one, and this one. That's not too hard. Now, sometimes we end up with domain and range where we've got like a word problem or a situation. Can we have negative people? Like, how many people are in this room? Well, right now it's just me and my dog just left. So, 1. I'm sure all of us have met negative people in their life where you ask them, how are you doing today? And they're like, oh, it's the worst. And then they start whining for 20 minutes and you find some reason to leave. But that's not a negative amount of people, right? So we can't have a negative amount of people. If we had negative 5 people in the room, what does that even mean? It's kind of silly. Can we be negative miles from the library? Let's say we are driving to the library. So we're 3 miles from the library, then we're 2, then we pass the library, and we keep going. When we keep going, we're not negative miles from the library. Now we're 1 mile, 2 miles, 3 miles from the library. It's always a positive number, or 0. So if there's a word problem in a situation, your domain is usually going to be x is bigger than 0, and your range is going to be y is greater than or equal to 0. Alright, that's about all you need for that.